Computing probability, and I have a theorem for you. We're at lesson 15.5. Before we get into this, I want to go over some definitions quickly. An experiment is an activity involving chance in which results are observed. A trial is each observation of an experiment. An outcome is the result of a trial. An event is a subset of all possible outcomes. A simple event is an event consisting of only one outcome. A compound event is an event made up of two or more simple events. And sample space is the set of all possible outcomes, and probability is the likelihood of something happening. I have a more detailed definition in a few minutes. And we've discussed permutations and combinations in this chapter. A permutation is an ordered arrangement of a set without repetition, and a combination is a selection of a group of objects from a set without regard to order. Okay? So if we perform an experiment like flipping a coin, the result is called an outcome. If it lands heads up, the outcome is heads. Heads is the simple event. And the sample space has two outcomes. Our set would include heads and tails. One event may be to get heads. When the outcomes of an experiment all have the same probability of occurring, we say that they are equally likely. If we roll a number cube, one die, with 6 faces numbered from 1 to 6, it's considered fair if each number is equally likely. So the definition of probability, we know it's the likelihood of something happening, but for us, for the math, if an event E can occur m ways out of n possible equally likely outcomes of sample space S, the probability of that event is given by this capital P with an E in parentheses. This is the probability of event E, or probability of event, where the probability of E is equal to m over n, okay? It's m ways out of n possible equally likely outcomes, okay? So, this notation, the P with the A in the parentheses or the E in the parentheses, can be read as the probability of event A or as a probability of A, okay? So remember that when you see the P and then the parentheses, okay? So what's the probability of rolling a 3 on a number cube? On a fair number cube, there are 6 equally likely outcomes. It's got 6 sides, 1 through 6, right? And there's only one way to get a 3 if we just roll one cube. Using our definition, we get the probability of 3 is equal to 1 over 6, 1/6. It's the number of ways to get a 3 over the total of possible outcomes. So the probability we roll a 3 is 1 out of 6, or 1/6 of the time. What's the probability of rolling an even number? So the event of the probability of rolling an even can happen in 3 ways, because there's a 2, a 4, and a 6 on that number cube, isn't there? So there's 3 ways that we can get an even number. On a fair cube, there's 6 equally likely outcomes, so we have 3 out of 6 ways. We have the probability of even is equal to 3 over 6, or 1/2. We can even say it's 0.5. What's the probability of picking an ace from a deck of 52 cards? Well, there's 4 aces in each deck, one of each suit, right? And there's 52 equally likely outcomes. There's 52 cards. So the probability of picking an ace would be 4 over 52. And we can simplify that to 1/13. It's the number of outcomes that lead to a particular event, getting an ace, over the total number of possible outcomes. See? So probability is a fraction. So here's my theorem for you. The probability of any event is a number from 0 to 1. If an event cannot occur, its probability is 0. It's got 0 chance of happening. If an event is certain to occur, its probability is 1. So look at this number line here. We go from no way of it happening, 0, to it definitely happening, 1. The likelihood of an event happening goes from 0 to 1 and between as fractions. So if we look at our probability of picking an ace, it was 4/52 or 1/13 when we simplified it. That would come out about right here of picking an ace out of that deck of 52 cards. Now, look at how close to zero this lands. See? Would you bet $1,000 that you'd pick an ace? I wouldn't. If it was over here, I might, but it's way over here closer to no way. See? And the probability of rolling an even number with a number cube, we saw that it was 1/2 or 0.5. That means if this is no way of it happening, and this is it definitely happening, we're right in the center here of picking, of rolling an even number on the die. See? It's 0.5. It's right in the middle. See? If 2 cards are picked from a deck of 52 cards, what's the probability that both of them are hearts? Well, there's 4 suits in a deck: hearts, diamonds, spades, and clubs. And since there's 4 suits, we can do the 52 cards divided by 4. That means there's 13 of each suit. So that means there's 13 hearts. So the number M of ways of picking 2 hearts is 13 choose 2. And the number of picking any 2 cards is 52 choose 2. We end up with the probability of picking 2 hearts is M over N. It would be 13 choose 2 over 52 choose 2. We can use our factorial notation and what we've learned in this chapter so far, and we know 13 choose 2 can be written like this. When we do the 13 minus 2, we're going to get an 11 down here, aren't we? We can write it with common 11 factorial to cancel them out, so we end up with 13 times 12 over 2. That gives us a 156 over 2, or divided by 2, which gives us a 78. And the 52 choose 2, we can do the 52 minus 2 down here and get a 50. We can write it with a common 50 factorial and cancel them out and just do 52 times 51. That's going to give us 2,652 divided by 2, which is a 1,326. We can simplify this to 1/17. So, 2 cards being picked from a deck of 52 cards that both are hearts is a 1/17 chance. See? 1/17 probability. What's the probability of rolling an 8 with 2 number cubes with a pair of dice? Well, each cube has 6 possible outcomes, 1 through 6, right? And we have 2 cubes, so we have 6 times 6. That's 36 possible outcomes. And there's 5 ways to get a total of 8. We can do a 2 plus 6, a 3 plus 5, a 4 plus 4, a 5 plus 3, and a 6 plus 2. And notice that I did 2 plus 6 and 6 plus 2. If this is a red die and that's a blue die, then the red die could be a 2 the first time and it could be a 6 the second time, see? So the probability of getting an 8 is 536. There's 5 ways to get an 8. There's 36 possible outcomes. The probability of 8 is 536. See? And you see how the 4 plus 4, there was only one of them? Okay? The probability of rolling a 7 with 1 number cube is 0. There's no way. There's only 1 through 6 on a die, isn't there? So rolling a 7 is out of the question. So that probability is 0. The probability of getting heads or tails by flipping a coin is 1. You're certain to get a heads or tails, but the probability of only getting heads is 1 over 2. It's half. There's 1 heads on 2 sides of the coin, isn't there? So your probability is half. If we roll 2 number cubes, are we more likely to get a 7 or a 12? Well, if we think, we can make a 7 with a 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6 plus 1. We can make a 12 with a 6 plus 6. And there's more ways to roll a 7, so it's more likely we will roll a 7. So the answer is 7. Okay? So our next lesson is going to be intersections and union of sets. We're going to get into compound probability. That's lesson 15.6. I hope I explained this well, and I hope you're doing well. And if I helped you in any way, please hit the like button and say hello to me down below in the comments. Let me know how you're doing. And I'll see you next video. Bye. Bye.